blocking factor. So number of I. So this is the brute force, the nested loop join case. Question? Same thing for the single loop, but single loop we can use the index for this one, not brute force. So for example, single loop, depending on types of index, it can be various. So it's always the same. You need to read the left-hand side, the driving table B over I. Then this is an indexing cost to read the driven table. Let me explain later. And this one is the same as the join, the factor, this one. You can see the join factor times I times S divided by block. Same. Then let's take a look at the index. Cost of reading driven table using index. If secondary index, X plus S. In case of primary key, X plus 1. Clustering index is a group of data, right? So you don't have to read each and every one, it's a group. So divide by blocking factor. And the primary index is 1 here. And hash is a little bit complicated. So we can just use H, but you don't have to worry about I'm eliminating. I ignore the hash cases, so we can ignore this one. Any question on the single loop join? So you should understand how we can get this one from the index. So that's the reason index without understanding index, it's very hard to understand. Sort merge is a little bit weird, because we need to know the overhead for the sort, right? And overhead for the sorting of the driven table. That is called the CS, roughly. Okay? Depending on the algorithm, depending on the DBMS, may be different. Then access the number of driven table, number of driving table, driven table, then we will get this one. Okay, let's take a look at the example, real example. So we have how many records? 10,000 records. And how many blocks? 2,000, which means blocking factor 5. You say divide. Then how many department? 125 department. And how many block? It's a 13 block for this one. Then which means you can calculate the blocking factor of the D. Divide by 13, that is the 9 point something. So which means it will be, no, it's a point. So 9 point something. So that is the 10. So blocking factor will be the 10. So these are the additional information from the catalog. The primary index of the D number of the department is X number is equal to 1, which means level 1 index. And secondary index manager social security number is level 2, and the S means the selection cardinality. Only one, unique for each data. And join selectivity is 1 over 125. Buffering factor of the ED means when you join employee and department, what is the blocking factor? So this one, blocking factor of this. You should know blocking factor of this also. Okay, it's not the same as the blocking factor of E, blocking factor of D, because you combine two. So that is the 4. Only the 4 rows for each block. So using this information, so we'd like to calculate the cost. How can you calculate the cost? We don't know which algorithm will be used. First, you need to consider which will be driving table. How many cases? 2 cases. So one is the employee. Another one is the department. Employee can be driving table. Department can be driving table. 2 cases. Then how many the index? How many index can you consider for the driving table? When you for the driven table, when you join with the employee, okay, then you can use the brute force. So nested loop join. So first case is the employee, then nested loop join, brute force. That is the first case. And second is D for nested roof joint. It's the second case. The third case is employee. Then when you access the department, DNO is equal to D number. You can use the D number index. Okay? Using single roof joint. Also same thing, single roof joint for the employee. So we can calculate. So this is a brute force, 2,000 block. 2,000 block plus 2,000 times this is how many? 13 blocks. Okay, 13 blocks. Then the joint selectivity is 1/125. That is here joint selectivity. Number of record. Divided by 4 means buffering factor of how many ion in this. That is, if you calculate this one, it's a 30,000 something. This one is the change in the order. Then for each department, nested roof joint. Same thing, 13 block, 13 times 2,000, and same thing, and it's 28,000. And J, this one is the employee. This one is employed by single roof joint. Single roof joint, we can use the X plus 1. It's the level of the index, D number. And for each, the employee. So then the others are the same, you can calculate, it's 24,000. And for the department, and we can use the index for the single roof joint. 13, 125 is what is 125? All the row of the department. Then try to match what? Manager social security number. So DNO is equal to D number. 2 plus as outer B. For the BNO, I think that this time we need the index information about the DNO for the employee. DNO employee is not here. I think I need to add DNO. That is actually the reason is that is in the previous case here. So DNO level 2 is from here. So we are going to use this secondary index DNO. Okay. Then that is the level is 2 and selectivity is 80. Okay. So it's total the 82. If you calculate this one, 12,000. Then which one will be selected in this case? Lowest one. So outer roof, department. Department will be driving table. Employee will be driven table. Then we can get the 12,000 IO. So this will be the lowest cost. This will be selected. Okay. So this is the cost-based optimizer, and the others are the thing. And let me quickly show you. It's already 17. Okay. Then if you are interested more about the cost-based optimizer, there is additional slide I uploaded. It's example of the Oracle optimizer. It's explain about the rule-based and the cost. All of them we discuss, but you can see the hint. Let's see the roof. Yeah, using hint. This is the to override decision of the query optimizer. Then you can give the hint. This is very useful when you are doing the database programming and SQL development. Then you can make the best query. Best means the fastest query using this kind of the hint. Okay, thank you, and have a wonderful Thanksgiving holiday. And but I hope probably you need to study for your final. So final exam will be the last week. So I announced I'm going to update the final exam schedule on the Canvas. Okay, so we will see on Monday next week. Thank you.